All right, everybody, welcome back again. Now, this is a question that if it says to state the domain, okay? If I'm asked to state the domain of a function, then, this is where we get into all real numbers, all positive integers, all counting numbers, things of that nature. Now, when you have a fraction bar, remember, when you have fraction bars, this guy is telling me, because of the fact that it's a fraction, that it's division. And because it's division, you cannot divide by 0. So you cannot divide by 0. That's a big no-no. Okay? What that tells you is that we are going to end up having some asymptotes. Okay? And up top, we have a square root. Okay? Now what this tells us is the square root, we cannot take the square root of a negative, because that gives us that wonderful I. And that I is great if we're graphing in a complex field. But since we're not graphing in a complex field, we're graphing on a typical Cartesian coordinate plane system, all numbers have to be real. So no infinities, no negative, or no square roots of negatives, no imaginary numbers. So first thing that we do is we're just going to take a look at these two in their parts. So if I take a look at the square root of 2x plus 5, I'm going to bring this guy over so that way we don't get it misconstrued with a different type of problem. What I need to find out is what's the absolute smallest number before it's negative. Well, the absolute smallest number before it's negative is 0. So it's got to be greater than or equal to 0. So I just solved this the way I would solve a normal equation. I'm going to look for, I'm actually going to, I'm going to negate the square root function, or the square root symbol, because it's not really relevant to what I'm looking for per se. So I go ahead and solve the equation. So subtract 5 from both sides. I end up with 2x is greater than or equal to negative 5. I divide both sides by 2. X has got to be greater than or equal to negative 5 halves. Okay? So there's our first restriction. Okay? We have to have a number bigger than 5 halves, or bigger than 2.5. Okay? Now we take a look at x squared minus 16. Now, what did we say? We can't divide it by 0. So we need to find out, where is it 0? So set it equal to 0. And then we just solve it. This is the difference of two perfect squares. You can solve this normally. You can, the way you normally would solve an equation. You can add 16 to both sides, take the square root, get plus or minus 4. But it is the difference of two perfect squares. And you're going to get x minus 4, x plus 4. Yes, you can get x plus 4, x minus 4. That doesn't change a thing. You end up with x equals 4, x equals negative 4. Okay? So now you have two other restrictions, here and here. So you have two asymptotes based on the denominator, and then you also have a restriction based on the numerator. Now, so your first inclination would be, okay, great, so I go from negative infinity to negative 4, and then from negative 4 to negative 5 halves, negative 5 halves to positive 4 to infinity. We can't do that. Remember, all numbers must be, you have to satisfy all of this. So all numbers have to be bigger than 2.5. So if I'm looking at a number line, and here's my 0. Now, once again, these units aren't going to be to scale, but we know that we have 1, 2, 3, 4, so here's negative 4. Negative 5 halves would be, here's a half, half, half. So negative 5 halves would be living right about there. So if every number has to be greater than or equal to this guy, then that negative 4, that asymptote created by negative 4, is actually not going to be included. So I don't need to worry about him. So my domain for this would be to go from negative 5 halves, and then I'm going to go forward to the point 4, and then I'm going to go from there, 4 to infinity. So that's what my function will look like. It has a stopping point at negative 5 halves. It has one single asymptote at 4, which is an infinite discontinuity, which you guys have talked about in class, just getting ready for the quiz. I hope this was helpful. Feel free to look back over it anytime. Don't forget to subscribe. That way when I put more of these videos up, you'll get them, and they'll help you out along the year. But happy studying, and we'll see you Monday.